Good morning to all. Myself G. Raj Priya, working as a assistant professor in Erode Engineering College in the Department of Electrical and Electronics Engineering. Today I am going to discuss the topic on transformer. So basically transformer is a static device. It means it does not have any rotating part. The function of transformer is used to transfer the electric power from one circuit to another circuit without changing frequency. It works on the principle of electromagnetic induction principle. So, it is used to transfer the electric energy from one AC circuit to another AC circuit without changing frequency. Next one, principle of operation. So transformer is working based on the principle of mutual inductance principle. So the mutual inductance means according to which an EMF is induced in a coil when the current in the neighboring coil changes is known as mutual inductance. And next one, working principle of transformer. So transformer basically consists of two windings, that is primary winding and secondary winding. The both windings are isolated from each other and wound on a common iron core. When the winding is connected to the supply side is called primary winding. When the winding is connected to supply side is called secondary winding. The primary winding has N1 number of turns and secondary winding has N2 number of turns. So in the primary winding is energized by an alternating voltage. It produces a alternating current. It will produce a alternating flux in the magnetic core. So thus the alternating flux links with the secondary winding. So the automatically EMF is induced in secondary winding according to the Faraday's law of electromagnetic induction principle. So next one, construction details. So the transformer based on construction again classified into two type, and first one is core type and second one is cell type. So core type mean windings around the core. It has only one magnetic path. In cell type, core surround the winding. It has two magnetic paths. So this is the overall construction diagram. In transformer consists of the following components. First one, silica gel, breather, conservator, transformer tank and filled with oil. So it has magnetic core, windings, insulation paper, oil and temperature gauge, breather, expansion tank and bushings. So first one, magnetic core. The magnetic core is consist of iron core. The core is made up of silicon steel material. So already I discussed about, according to the core construction, it again classified into two type, core type and cell type. So core type mean windings around the core. It has only one magnetic path and two limbs. For cell type transformer, the core surrounds the winding. It has two magnetic paths and three limbs. The core is mostly we preferred a silicon material because to reduce the hysteresis losses. So the magnetic core consists of iron core. The transformer core generally is laminated and made up of silicon steel material. And next one, winding. We already discussed in transformer has two type of winding, that is primary winding and secondary winding. When the winding is connected to the supply side is known as primary winding. When the winding is connected to the load side is known as secondary winding. So both windings are made up of copper material, and there is a no physical connection between primary and secondary winding. And next one, insulation. Here paper is used for the basic conductor insulation. Mostly we preferred a enamel type insulation used for low voltage transformer. Next one, oil. So here oil is used for two purposes. First one, protect the moisture and remove the heat produced by the coil. So oil is act as a cooling and insulating purpose. So every oil tank has provided with a oil cage. So the purpose of oil cage is used to indicate the oil level present inside the tank. In case any oil leakage beyond the limit, it will provide some alarm. So the property of oil has dielectric strength, low viscosity to provide good heat transfer, and free from inorganic acid, like this. So next one, temperature gauge. Every transformer has provided with a temperature gauge. It is used to indicate the hot oil level or hottest temperature. So next one, breather. So the purpose of breather is used to prevent the entry of moisture and allow the dry air into the transformer tank. So it is made up of silica gel or calcium chloride. It absorbs the moisture and allow the dry air into the transformer tank. So the breather is connected in the one side of conservator. So next one, expansion tank. So the expansion tank is also known as a conservator. A small auxiliary oil tank may be mounted above the main transformer tank and is connected to the main tank by a small pipe connection. The function of expansion tank is used to keep the transformer tank full of oil dissipate expansion. The function of expansion tank is used to absorb the vapor. A small pipe connection between the gas space in the expansion tank and cover the transformer tank permits the gas above the level it pass into the expansion tank. So the automatic transformer tank will be completed with filled with oil. And next one, Bucka's relay. So the purpose of relay is used to, in any fault condition, the relay will give the warning. So the first warning that a fault is present may be given by the presence of bubbles in the oil. If the transformer is fitted with a conservator and there are no packets in which gas collect, the gas bubbles will rise up the pipe joining the conservator to the tank. So it is not possible to mount gas operated relay in this pipe to give an alarm in case of minor fault and to disconnect the supply from a severe fault. Next one, bushings. So the connection from the transformer windings are taken by the help of bushing. So porcelain insulators can be used to up to voltage of 33 kVA. Above 33 kVA, capacitor or oil filled type bushings are used. So these are the construction details of transformer. And next one, EMF equation of transformer. So EMF induced in primary winding is E1 equal to 4.44 into F into 5M into N1. Here E1 means EMF induced in primary winding. So F is a frequency of AC supply in hertz and phi m is a maximum value of flux in the core in Weber, and N1 means number of turns in primary winding. So similarly, EMF induced in secondary winding equal to 4.44 into F into phi m into N2. So here N2 is number of turns in secondary winding. So we already know that phi m equal to Bm into A. So Bm means maximum value of flux density in core Weber per meter square, and A is a area of core in meter square. So the EMF induced in primary winding or secondary winding, replacing phi m equal to Bm by A. So finally we get E1 equal to 4.44 into F into Bm into A into N1. And next one, transformation ratio. So the transformation ratio is the ratio of secondary voltage to primary voltage. It represented by K. So K equal to V2 by V1. So depending upon the K, the transformer again classified into three type, that is step up transformer, step down transformer and auto transformer. So step up transformer is the K value is greater than 1. So the step down transformer is K value is less than 1. So for K equal to 1 means it means a auto transformer. So based on construction, it classified into two type, that is core type and cell type. Based on voltage output value, classified into three type, that means step down, step up and auto. Based on the input supply, again classified into two type, that is single phase transformer and three phase transformer. So next one, application of transformer. So the application of transformer, it is used in electrical power engineering for transmission and distribution. So we have for the transformer used in transmission purpose and distribution purpose. So in transmission distribution, we will use a step up transformer or step down transformer depending upon the availability. And next one, as an instrument transformer, is used for measuring the current and voltage. So for measuring current, we preferred a current transformer. For measuring voltage, we preferred a potential transformer. And next one, used in radio and TV circuits, telephone circuits and instrumentation circuits. So last one, the furnace and welding transformer. So these are the application of transformer. As a step down or step up transformer to get reduced or increase the output voltage depending upon the availability. So these are the construction details and EMF equation of transformer and application of transformer. So thank you.